Hey guys, today we're going to do chapter 13, part 1. This is just on basic solutions. Let's dive right in. One of the first things you need to know about solutions is you need to remember from chapter 3 that solutions are just a homogeneous mixture, which remember means that two or more substances are mixed together with the same, they're mixed together evenly. All right, another thing for solutions is that solutions come in all states of matter. We're going to look at that on the next slide. There we go. So there's gas solutions like the air. There's gas and liquid like soda, like the bubbles in the soda. Liquid solutions are like rubbing alcohol, hand sanitizer, things like that, or even those little water flavors that are liquid. That would also be a liquid solution. Solid and liquid is what we normally think about for solutions. So like salt water or sugar water, things like that. And then of course there are solid solutions like brass or any other alloys like steel, things like that. All right, next thing with solutions we're going to talk about are solvent and solute. These two pieces make up a solution. So the solvent is the main piece, and the solute is the smaller piece, normally what we're dissolving, and together they equal the solution. Okay, in a water-based solution, we call these aqueous because water is the solvent. Okay. Just remember from last chapter, in chapter 12, we did discuss likes dissolve likes. So remember, polar dissolves in polar substances, or polar substances will dissolve in a polar solute like water, and nonpolar substances will dissolve in a nonpolar solvent like hexane or toluene. Also remember that ionic dissolves in polar, not nonpolar, and polar. Remember, really, ionic is so polar that they separated, so ionic is very similar to polar. They're just legitimately in like different pieces versus polar compounds, which are together still. If you don't remember how to find polarity, you need to go back and look at chapter 10 where we discuss polarity. All right, we also saw this image in chapter 12. So this is those ion dipole forces where the water comes in and attacks the salt. Any type of salt, any ionic compound. So when that happens and the water comes in and attacks it, the positive hydrogen side is going to be attracted to the chlorine. And the negative oxygen side is going to be attracted to the positive cation, which in this case is sodium. So it's not always chlorine, it's the anion that the hydrogen side is attracted to. You may have to draw these, so just remember opposites attract. The hydrogen side of the water will always be the positive side, and the negative side of the water will be the oxygen side. Hydrogen is positive, oxygen is negative. That goes back to our electronegativity chart. Also, remember from chapter 7 when we did reactions, that ionic compounds, when we say that they're aqueous, they break apart into their ions. So here we put sodium chloride into our solution of water, and the sodium chloride ions break apart. All right, so this is a pretty lengthy slide. Please make sure to pause here so you can go ahead and write everything. Solubility is just a measure of how many grams dissolve in a specific amount of water, normally 100 grams. Or 100 milliliters. So then we have saturated. Saturated means that all that can dissolve will. So in this example of sodium chloride, there's 36 grams of sodium chloride that can dissolve in water. If I have 36 grams of it, that would be saturated. Unsaturated would mean there's less than the maximum amount. So like, let's say I have 25 grams of sodium chloride dissolved in water. Well, I could still dissolve more, but I don't necessarily have to. We would just say that it's unsaturated. Supersaturated is a special condition. That means it can hold more than the normal amount. So let's say I dissolved 40 grams. Again, it is a special situation. So We'll talk about how to do that in a few minutes. So back to our separation of the compounds. Remember that electrolytes, these specifically are going to be ionic and soluble, which means they do dissolve and they conduct electricity and they're ionic. If they're non-electrolytes, these are generally covalent. I'm just going to put /molecular. They do dissolve, but because of that, they don't conduct electricity. Because there's no ions, none of those charges are present to conduct that electricity that's needed to be conducted. So this is back to solubility. There will be a chart like this in mastering. There could be one on a test or a quiz. So it is important that we go over this. So solubilities, and you can see all of these are increasing as temperature rises. So as we go this way on the chart, all of them have an increasing slope. So all solid solubility will increase when we increase temperature. Now they do vary by the type of compound it is or what compound it is, but they still increase. More will dissolve at a higher temperature. So if we look and we were to graph, and let's say we've got 40 Celsius, and let's say we've got, I don't know, about 38 grams of KCl will dissolve at 40 Celsius. If I have that, we would say that that point is on the line. And on the line will be considered saturated because I can't dissolve any more. If I do, we would call that supersaturated, which again is a special condition. If let's say I say we've got 30 grams at 40 degrees Celsius, that's below the line. We're still talking about for KCl. So below the line is unsaturated. And then let's say we've got 50 grams. If we are above the line, we are supersaturated. This is just if they're asking you to compare them. Otherwise, they may say, how many grams of KClO3 will dissolve at 60? Oops, sorry, wrong way. So we go up here, we plot the point, I don't know, 24 grams. KClO3 will dissolve at 60 degrees Celsius. Okay, so that's just how we would do that. On mastering and on a test or quiz, I would give you a range that would be acceptable for that. So, all right, next thing, how we make supersaturated solutions. So the way we do this, it's called recrystallization, and it's a way that we purify a solid. The most common thing, or the thing that y'all are most used to that would be like this, is rock candy. So what happens is you put the solid into the water and you heat it up. Then you have to let it cool back down very slowly. It could take days. But as you do that, the stuff that you dissolved, so in rock candy, sugar, it will recrystallize and it will be a more pure form of that sugar, which is why rock candy actually tastes better than like hard candy. So if you want to look, you can make rock candy at home. It's not that hard. You just have to have patience and space to do it with. Okay, one of the last things we're going to talk about in this video is the solubility of gas in a water. So what you need to write for this one is up here. Solubility of gas does decrease as you heat it up. So think about soda on a hot summer day. If you leave a soda in the car and you go into Walmart and you come back out, your soda is probably flat. That's because all of the bubbles that were in the solution are now out of the solution because your solubility decreased. So now it's not as fizzy. So as temperature increases, solubility of gases decrease. So a warm soda, when you pour it out, will fizz more than a cold soda. And y'all should know that if you put a soda in the fridge, it's going to stay bubbly longer than if you leave it on the counter. Okay. Also, you need to keep in mind that the higher the pressure of the gas above the liquid, the more soluble the gas is in the liquid, which means the more bubbly it'll be. So this goes back to sodas. This is why they are pressurized. because the more pressure I can make the container have, the more bubbles are in the solution. So when you open that can of soda or even that bottle of soda, it makes that fizzy sound. That means it's lowering the solubility. The fizz is coming out of your soda some. But just remember, it fizzes more if it's hot, so we want to keep it as cold as possible if you like a really fizzy soda. All right, that's it for part 1. You'll have a great day.